So today we're going to look at section 7.5, strategies for integrating. And so the first thing you're going to need is you're going to need your integration formulas. And you're going to want to look at page 519 and make sure that all of the formulas that you have written down on your integrations page are the same ones that are in the book. There are a couple from your sheet that are missing unless you wrote them down in previous sections. So go through 1 through 20 on page 519 and make sure each of those is on your note sheet. Alright, and so we're going to look at the different steps that we can use to integrate functions, because we've learned 3 different ways of integrating functions. We've learned to use partial fractions. We've learned to use their trigonometric identities. We've learned to use U-Substitution and Trig Substitution. And so we're going to kind of combine all of those different methods into this particular lesson. And so we're going to look at our different steps that we can take to try to solve these different difficult integrals without losing our minds. Okay, so our first step is to try to simplify, if possible. Our second step is to look for something obvious to substitute, so we could either use our Trig substitution or our U-Substitution. The third step is to classify the integrand according to its form. So if it has the specific form of a trigonometric integrand, then we could classify that and use that information to integrate. And the last step is, if none of those things seem to really work, then we're going to try everything we know to get it to be something simple that we can integrate by hand. So we can try substitution, U-Substitution, or trigonometric substitution. We can try to integrate it by parts. Or we can try to manipulate the integrand and turn it into some type of partial fraction. Alright, so the integral of tangent cubed of x divided by cosine cubed of x dx. First thing it asks us to do as one of our steps was to simplify. So I'm going to try to break this into 2 separate fractions and see if I can simplify it that way. So I'm going to pull out that cosine cubed and make it the fraction 1 over cosine cubed of x, since it's on our denominator. And what do we know 1 over cosine is equivalent to? Anybody remember? You're close. Secant. Okay, so 1 over cosine is equal to secant, so I can rewrite this as tangent cubed of x times secant cubed of x dx. Okay, so we've done trig substitutions before when solving things like cosine sine or tangent secant. So we remember back, what do we let u equal when we have in the form tangent cubed secant cubed? We know that our tangent is odd, so we're going to use that information to tell us what we're going to substitute. Back in section 7.3. Or maybe it's even 7.2. Looks like maybe. U secant of x, okay. And what is d equal? Okay. And then we know tangent squared of x equals, okay. So those are going to be our three substitutions that we're going to use. If I pull out a secant tangent, I end up with tangent squared of x times secant squared of x times secant squared, or secant of x, tangent of x, dx. So all I did was pull out one, factor out one secant, and factor out one tangent. So then I can start using my U-substitution. So tangent of x is the same thing as secant of x minus 1, and secant we know is u, so this is like u squared minus 1. Secant becomes u, so then that becomes u squared. And secant tangent becomes du. Perfect. So I'm going to distribute my u squared and get u to the fourth minus u squared du. Okay, so what is the integral of u to the fourth? U to the fifth over 5. And what's the integral of u squared? Okay, u cubed over 3. Then we always add plus c. And if we back substitute what u equaled, u is equal to secant. So we get secant to the fifth of x over 5 minus secant cubed of x over 3 plus c. Okay, so when you say like trig identities, try to simplify them, try to turn them into a form where we can use trig substitution or use U-substitution. Alright, so if I'm looking at example 2, I'm given the integral of e to the square root of x dx. Now I know that the integral of e to the x just stays e to the x, but this is e to the square root of x, so I'm going to try to turn it into something a little simpler. So I'm going to use U-substitution to where u equals the square root of x. I don't know where 3 came from. Square root of x. Okay, if I solve this for x, then x is the same thing as u squared, because I would square both sides to get rid of the square root. Which tells me that dx, what I'm going to replace my dx with, is going to be, if I differentiate u squared, I get 2u du. So I'm plugging all of that in. The square root of x is now u, so I get e to the u. And du is 2u du, or dx is 2u du. Okay, so we get something a little simpler. I know I can pull the 2 out front and give 2 the integral u e to the u du. But that's only partially simpler. So the second thing I'm going to do is integrate by parts. G prime of x equal e to the u, then I know g of x is also equal e to the u. And if I let f of x equal u, then I know f prime of x is equal to 1. And so what's my formula for integration by parts? F prime of x? Yeah. Dx. Okay. Alright, so first I have to remember is that I have this 2 out front that I pulled to the front. That's important. So we're going to keep that 2 out front when we integrate. So then I have f of x, which is equal to u, times g of x, which is equal to e to the u, minus the integral g of x, which is still e to the u, times f prime of x, which is 1 dx. So, if I continue then to integrate, I still have that 2 out front, u, e to the u. E to the u times 1 is just e to the u, so I can ignore that 1. And the integral of e to the u we know is e to the u plus c. And if I distribute that to the important pieces, you don't have to distribute it to the c, I get 2, down below, 2u e to the u minus 2 e to the u plus c. So far, so good. Distributed the 2. Makes some sense. 2 times any constant is just a constant, so you don't have to distribute the 2 to the c. And then if I back substitute what u equaled, remember u equaled the square root of x. So if I back substitute that in, I get 2 square root of x e to the square root of x minus 2e to the square root of x plus c. Okay, so if it looks like something easy, here's U-Substitution. You can combine U-Substitution and integration by part. You can combine lots of different things. This is all about finding strategies that work. And lastly, if I look at example 3, I have x minus 1 divided by x squared minus 4x minus 5. Okay, so we're dealing with fractions, so what do we think is going to be the best way to solve it? Factor the denominator, perfect. So let's use partial fractions, so we'll factor the denominator. Okay, so what is x squared minus 4x minus 5 factor to? Perfect. X plus 1, x minus 5. Okay, so if I know that's my new denominator, then I'll rewrite this as a over x plus 1 plus b over x minus 5. And that's going to equal this fraction, this numerator up here. So let's find common denominator. So I'm going to take a times x minus 5. I'm going to take b times x plus 1. Okay, so a times x minus 5 is a x minus 5 a. B times x plus 1 is b x plus 1 b. And remember I said that equals my numerator, which is x minus 1. Okay. If I factor out in my x, I get a plus b times x plus negative 5a plus 1b equals x minus 1. So then in grouping things, this is like a 1x. So I know that a plus b equals 1. In grouping this other part, I know that negative 5a plus b equals negative 1. So if I want to try to solve these for a and b, I'll start with solving this one for b. So if I add 5a to each side, I get b equals negative 1 plus 5a. Which I can then back substitute over here to solve. So I get a plus negative 1 plus 5a equals 1. And combining my terms, I get 6a minus 1 equals 1. Yep, so we add 1 to each side. So 6a equals 2. So what does a equal? Yep, so 2 over 6, which equals 1 over 3. Okay. So then if I plug that back in up here, then I can solve for b. So I get b equals -1 plus 5 times 1/3. Since I know I'm going to be dealing with denominators of 3, I'm going to rewrite this as -3 over 3. That's the same thing as -1 plus 5 over 3. So what does b equal? Yep, 2 over 3. Perfect. Okay, so then in simplifying this partial fraction, my a get 1/3 over x plus 1 plus 2 over 3x minus 5. Okay. So like I said, this is just about finding strategies at work using the different methods that we've learned so far and using that table of common integrals. So you're going to do 523, 1 through 20. We're going to work on this today and tomorrow because I know that sometimes it's hard to come up with the strategies on your own when you're looking at the problems. So we're going to take a couple days to do it.